In this question, we are now working with our special triangles, 30, 60, 90, and 45, 45, 90 triangles. We are given the hypotenuse, and we are asked for the longer leg. In the 30, 60, 90 triangle, it is always easiest to work from the short leg. How do I know which one is the short leg and not just saying, like, it looks like it's the smallest? But how do I know for sure? Smallest angles make smallest sides. So across from the 30 is going to be the smallest side. What's the relationship between the small side and the hypotenuse? Half double relationship. So what is the small side? 5. We weren't asked for that though. We were asked for x, which is the longer side. What's the relationship between the small side and the long leg? Times the square root of 3. But it is always easiest to work your way back to the short leg first in the 30, 60, 90. So hypotenuse to short leg is a double relationship. Long leg to short leg is a square root of 3 relationship. So on the next one, again, we're given the hypotenuse. What would the short leg be? 7.5, half of the hypotenuse. And what would the long leg be, even though we weren't asked for it?
7.5.
Good point. Thank you. I said no decimals. 7.5 I'm fine with because that's clean. I didn't do any rounding or cutting off there. So that's fine. But something like a square root would be a really ugly decimal. So I don't want ugly decimals. But 0.5s, 0.25s, those things are okay. I want to do one more example of these. Let's say I was given a long leg of 6 and asked for a hypotenuse. What's the relationship between the long leg and the short leg?
Wouldn't it be 36, or like 6 to the third power?
What's the relationship between the long leg and the short leg?
The square root of 6.
I multiply by the square root of 3 to get to the long leg. So if I'm trying to get back to the short leg, what do I need to do? Divide. The opposite of multiplying is dividing. So I need to divide by the square root of 3 to get back to the short leg. Like in the last part, I multiplied 7.5 by the square root of 3 to get to the long leg. So if I'm trying to work my way back, the opposite of multiplying is dividing. So I need to divide by the square root of 3. Now, once again, we've talked about how it's kind of inappropriate to leave them, but I'm going to ask you to just leave them. Okay? Don't fix your square roots on the bottom. Just let them be. Then, how do I get from long leg to hypotenuse? Double it. So I would have 2 times 6 over the square root of 3, or 12 over the square root of 3. Okay? Please do not fix your square roots on the bottom, even though the back of the book says to. The other special relationship is the 45, 45, 90. In the 45, 45, 90, both of the legs have the same length, so both of the legs would be 2, and what's the relationship to the hypotenuse? Times the square root of 2, so 2 square roots of 2. Again, if you were given the hypotenuse and needed to work back to a leg, you would divide by the square root of 2, because that's the opposite of multiplying by a square root of 2. In the last type of question, the directions will say something like approximate, estimate, or use a calculator. So in these questions, decimals are appropriate answers. When a problem says solve a triangle, what they mean is find out everything about that triangle that we don't know. Triangle has 6 parts, 3 angles, 3 sides. Angles are named with capital letters, sides are named with small letters. So we're given an angle of 19 for A, a side of 13 for B, and we're given one more thing. What else are we given? Angle C is 90. So we have 3 pieces of information to find. One of them requires no trig. What is angle B? 71. How do I find an angle when I'm missing 2 angles?
180.
Subtract from 180. The 3 angles of a triangle have to add up to 180. For the 2 missing sides, we need to use some trig. It didn't tell us where theta is. What I always do is let the given angle be theta, not 90. Theta can never be 90. But I'm going to let A be theta, since that's when I was given, because I know myself, and I tend to subtract 61 instead of 71, and I use that, everything from that point on is going to be wrong. So I try to not use any answers that I've found if I can avoid it. So I'm going to let theta be the given angle. So what kind of a side is B then? Adjacent. What kind of a side is A? And C is our hypotenuse. So if I want to solve for A, I need something that uses opposite and adjacent, because the adjacent is what I'm given. And if I'm going for A, that's our opposite. So which trig function uses opposite and adjacent? Tangent. So we're going to set up the tangent of 19. Remember, an angle always goes with the trig name, is equal to opposite A over adjacent 13. To get A alone, what do I need to do? Multiply both sides by 13. Kind of ran out of room. To get 13 tangent 19 equals A. And we type this in the calculator. If you're using a graphing calculator, make sure that in your mode, on the third line down, it says degree as the darkened word. So if you're using a graphing calculator, press the mode button, which is in the top row, and make sure the third line down, the word degree is the darkened one. Otherwise, you will get some very strange answers.
Wait, so we can't, for A, we just can't say like 13 over the square root of 3.
This is not a 30, 60, 90 triangle. So those special patterns don't apply to this one. Those special only apply when the angles are 30, 60, and 90. So we type in 13 tangent 19 to the calculator, and what do we get?
4.4762.
About 4.5-ish. Go to 1 or 2 decimal places. We don't need tons. If you feel really good about that first answer, you could use the Pythagorean theorem to solve for C, because now we know 2 sides in a right triangle. If you think there's a possibility you may have gotten that wrong, then you might not want to build more answers off of it, because then they will definitely be wrong. So if I'm going to try to not use it, then now I need a new trig function. I'm still going to use A, I'm still going to use adjacent, but now I want to use hypotenuse. Which one uses adjacent and hypotenuse? Cosine. So I'd say the cosine of 19 is adjacent 13 over hypotenuse C. When our variable's on the bottom, we multiply both sides by that variable, which cancels out the fraction but does not get our variable alone. So what do I need to do to get the variable alone? Divide by the cosine of 19. So on the calculator, I would type in 13 divided by cosine of 19. And what do I get? 13.75-ish. Okay. So we do 13 divided by the cosine of 19, which gives us about 13.75. Okay. Questions?
Wouldn't it be like C over the cosine of 19?
The cosine 19 is canceled on the left-hand side, so it's just a C now.
So the C and cosine of 19 are really like one.
No, it's a product. It's C times the cosine of 19. So I divided by the cosine of 19 to get C alone.
I still don't understand. Like, I'm trying to find the C, right?
Yep, I'm trying to find C. So cosine is adjacent over hypotenuse, so 13 over C. To clear a fraction, you multiply both sides by the denominator. So I multiplied both sides by C, which cleared my fraction but didn't get C alone. And I need C alone, so then I divide by cosine 19. So that I have just a C remaining on the left, and on the right, 13 divided by cosine 19.
Wouldn't that cancel out? Those two cancel out? Like the cosine 19 and cosine 19.
Yes, it cancels the two cosine 19s, which leaves me with just C on the left. But on the right, I still have a divide by cosine 19.